as this is Dr.Senthil Kumar, Associate Professor, Department of EEE, SNS College of Technology, Coimbatore. Now in this the video series, we have discussed about feedback amplifiers, and the last video series is the Schmitt Trigger, which comes under the course Analog Electronic Circuits 23 WT104. Schmitt Trigger. A Schmitt trigger is a circuit which consists of 2 transistors and 4 resistors, and here we are utilizing transistor for this Schmitt trigger circuit. Basically, you know about the 2 types of signals in electronics. One is analog signals and another one is digital signals. For many applications, we have to convert analog into digital signals and digital into analog signals, what we discussed earlier. The surrounding environment consists of analog signals, and whereas all the digital electronic components are performed using digital. There are many circuits to convert analog to digital, and one of the basic circuit with the help of a transistor, with the help of a simple transistor, is Schmitt trigger. See the application part of this Schmitt trigger is shown. You may visualize the waveform which is given in the right bottom. It is given in the right bottom, where a sinusoidal signal, I mean it is an analog in nature, continuously varying, which is converted into a pulse, a digital pulse signal, which is green in color. The red is a sinusoidal signal, whereas the pulse is the green in color, which is a digital signal. The application may be analog to digital, a comparator, a on-off controller, a signal conditioner, and sine square wave generator, noise reducers, goes on. There are various applications here. And now let me see a Schmitt trigger which is based on the BH curve of hysteresis loop. Hope you know that what is hysteresis loop. You have studied your physics, and let me extract the hysteresis loop waveform into a square pulse with the help of a Schmitt trigger. Now see here the circuit diagram. As I said, it consists of 2 transistors, which is T1 and T2, and there are 5 resistors. So that a simple Schmitt trigger circuit where it converts analog signals into digital signals. Therefore, the 2 transistors will acting as a switch whose threshold value is determined with the help of a BH curve. Whose threshold value is determined with the help of a BH curve, where one transistor, when the threshold value is fixed, when the input value crosses this threshold value, there may be a change. It may be in one state, the transistor may be in off state, and if the threshold value crosses, it may be in the on state, or vice versa happens. Similarly, for the transistor 2, a threshold value is fixed in some way with the help of the biasing resistors, which is connected in the base of the transistor 2. Similarly, a biasing resistor which is connected to the collector emitter terminal of the transistor 1 will give a threshold value for the transistor 1, and similarly for transistor 2, the base resistance and the collector resistance will decide the threshold value in order to fix. Whenever the input signal crosses the threshold value, then there may be a change. The transistor may be, let me assume that the transistor is in off state, it may be changed into off, and let me assume that the transistor is in on state, then it is changed into off. It goes on. Now see the BH curve of the BH curve of the threshold value, the BH curve which is given, you mean as nothing but the hysteresis curve. So nothing but the hysteresis curve. For the green, on the right hand side, for the green, the threshold value is set such that it may be a upper threshold value VUT. right? Upper threshold value VUT. If a transistor crosses, if the input signal of one transistor crosses the upper threshold value, then there may be a changes from high voltage to low voltage. Similarly, if a signal crosses the lower threshold value, then there may be a chance in a transistor that it may be changes from low to high, right? Which is represent in the BH curve as yellow color line, where it is from high to low, and the green color represents from low to high. Green color represents the low to high. Therefore, the difference between the upper threshold value, upper threshold voltage, or, or the value upper threshold, and lower threshold value, the hysteresis width occurs. The width of the hysteresis loop. Similarly, the width of the pulse, the output pulse we can obtain, depends on the difference between the VUT and VLT, upper threshold and lower threshold voltage. Now see with an example which is given here, the right hand side, there is two waveforms. One is an analog waveform which is continuously changing with its nature, which is given in the top, and the lower threshold value is mentioned in terms of a red color, which is usually shown there, and the green color, green horizontal line, which is nothing but the upper threshold value. The waveform, the blue color, the dark, the blue color waveform, which represents the input analog signal, which is irregular or regular, whatever may be. If the input waveform crosses the lower threshold value, see there is the output. See the output waveform, which is mentioned in a dark blue or pink color, or violet. It seems it's violet color, where the lower the transistor, one transistor may be in off state, which is turned into on state, where the voltage level changes from 0 to 5. You mean from low level to high level. Similarly, and the duration of the high level is such that the input signal from the upper threshold crosses to the lower threshold, then the difference between the upper threshold and the lower threshold value is maybe the on state, and similarly the difference between the lower threshold to the upper threshold, it may be in off state. So it is clearly mentioned, and the waveform, the input waveform is the analog signal, which is in the top, and the output waveform, which is bottom, which is in violet color, right? Depends on the threshold value, the transistor may be turned on and turned off. The another application is also given here, given below, right? The transistor T1, which may be turns on from on to off, depends on the threshold, and T2 depends on the threshold value. Hope you understand this concept, and the operation in detail, which we explained in the next video series of the Schmitt Trigger. Thank you for patient listening, and hope you understand the application of Schmitt Trigger. Thank you.